Hey, what's going on, everybody? Welcome back to Civil Engineering Academy. My name's Cody. Let's go ahead and get started. So today we have a vertical design problem, and in particular, we're going to be talking about some stopping sight distance. So here's what the question says. A 60-foot major arterial has a design speed of 50 miles per hour and services approximately 1,000 vehicles per hour per lane. Calculate the stopping sight distance at a positive 2% grade. Use the reaction time of 2.5 seconds and a deceleration rate of 11.2 feet per second squared. And then we see our four options there available in feet. So, trick to this problem is, can you find the formula that you need? So if you are in the FE manual, you can find it on page 299. And so notice on page 299, they don't give you a reaction time, they don't give you a deceleration rate, so it's given to you in the problem. For the PE, you're going to have to go outside of the manual. So if you're taking the PE exam, you're not going to be in the manual. Policy on Geometric Design of Highways, that's going to be the book that you are looking for. It's also called the Green Book. So you can find that on, I use the 2018 version, 2018 Green Book, and you can find it on page 3-5. And in particular, section 3.2.2.3. And so something that you'll also notice is on page 3-5, it gives you the 2.5 seconds for the reaction time. And so if it doesn't provide that to you in the problem, you can find it in that section. And the deceleration rate was actually found on page 3-12. So those are typical numbers that they want you to use for design. So whenever you look on those pages, you will find a formula that looks very similar to this. SSD, so stopping sight distance, is equal to 1.47 times your design velocity times your time plus or design speed, your velocity squared over 30, and then we're going to go open parentheses, A over 32.2 plus or minus the grade, and boom. So there's the formula that we're going to use. Let's go over our unknowns: velocity, our design speed. We know that's 50 miles per hour. We know our reaction time of 2.5 seconds. We know our deceleration rate, which is A, of 11.2 feet per second squared. And we also know our grade. It gives us 2%. And so notice, here's a trick that they can get you on, is that grade is feet over feet. Okay, so we're not going to use 2% in this case. It's going to actually be 0.02. Okay, so something to keep watch of that can trip you up on the exam. So plugging in stopping sight distance is equal to 1.47 times the velocity, the design speed, which is 50 miles per hour. And we need to multiply that by our reaction time, which is 2.5 seconds. And then we need to add our design speed again. So design speed is 50 miles per hour. We need to square that. We're going to put that over 30 times our deceleration rate, which is 11.2 feet per second squared. Then we're going to put that over 32.2. And then we need to add our grade. And so since it's a positive grade, we add it, 0.02. I'm going to redraw that plus sign. There we go. And so, hey, while I've got you here, if you've already enrolled in one of the review courses on Civil Engineering Academy, keep it up. You can do this. If you're not enrolled, I encourage you to go to civilengineeringacademy.com to check out some awesome practice exams and resources to help you pass your FE and PE exams the first time. So with that said, whenever you solve this guy out, you should end up with 410.31 feet. So that is your exact stop distance there. However, we see that's not an option in A through D. So to be conservative in engineering, in this case, we want to round up. We want to give that extra 0.7 feet, 0.69 feet and we're just going to round up to 411 feet. So the answer is going to be D on this one. So I hope this video helps, and we'll catch you next time.